Good morning, students. Previous class we have solved exercise 5A problems. Second Roman few problems we have completed, and this is the fifth question. Find the equation of the tangents drawn to the hyperbola 2x square minus 3y square equals to 6 through minus 2 comma 1. Here through minus 2 comma 1 is mentioned. That means we are not required to find out the equation of the tangent at px1 y1. Had it been the case, then we would have taken s1 equals to 0, equation of the tangent at px1 y1 to the curve. The curve may be a circle, ellipse, hyperbola, parabola, whatever it is. So s equals to 0 is s1 equals to 0. Equation of the tangents drawn through minus 2 comma 1. That means, for example, this is the hyperbola. So from this point, so these are the tangents. These are the tangents. So this is the px. This is px1 y1. So the equation, the combined equation of the pair of tangents drawn from p x1 y1 to the curve s is equals to 0 is s1 square is equals to s into s11, which we have seen in the circles, parabola, ellipse, and now hyperbola. So s1 square is equals to s into s11. So s is this. So x1 y1 is this point. We can do this problem in an other alternative as well. So which is given equation of the hyperbola is 2x square minus 3y square is equals to 6. X square by 3 minus y square by 2 is equals to 1. Implies a square is equals to 3, b square is equals to 2. So, required tangent. Let the equation of the required tangent be y minus y1 equals to m into x minus x1, whose slope be m, and p x1 y1, the point is minus 2 comma 1. Implies y minus 1 is equals to m into x minus half minus x plus 2. So this is equals to y is equals to mx plus 2m. This minus 1 if you transpose plus 1 is equals to 0. So this is clearly of the form y is equals to mx plus c. Since this line is a tangent to the hyperbola, implies the condition for the tangent C is c square is equals to a square m square minus b square. So here c is 2m plus 1 whole square is equals to a square is 3 m square minus b square is 2. This is equals to 4m square plus 1 plus 2 to the 4m is equals to 3m square minus 2. So this implies 4m square minus 3m square is m square plus 4m, 1 plus 2 is 3 equals to 0. 1 3 is a 3, 3 1 is a 3, 3 plus 1 is 4. So m square plus m plus 3m plus 3 equals to 0. This implies m into m plus 1 plus 3 into m plus 1 equals to 0. From this, m is equals to m plus 1 equals to 0 or m plus 3 equals to 0. Therefore, m is equals to minus 1 or m equals to minus 3. So, m equals to minus 1 you take, and the point x1, y1 is this. So, slope point from you take, then one equation of the tangent we will get. In the similar way, m equals to minus 3, point P x1, y1 is this. So, y minus y1 equals to m into x minus x1, another equation of the tangent we will get. So, in this way, we will be getting the two individual lines. But if we do s1 square is equals to s into s11, then we will be getting the combined equation of the pair of tangents. So case 1, m equals to minus 1, p x1 y1 is minus 2 comma 1. So equation of the tangent is y minus y1 equals to m into x minus x1. So y minus 1 is equals to m equals to minus 1 here, x minus of minus. So this is equals to y minus 1 equals to minus x minus 2. Therefore, x plus y, this minus 2 if you transpose plus 2, 2 minus 1 is plus 1 equals to 0. And the second one is, if m equals to minus 3, p x1 y1 is equals to minus 2 comma 1. So the equation of the tangent having slope m and the point x1 y1 is y minus y1 equals to m into x minus x1. So y minus 1 is equals to minus 3 into x minus of minus 2 is x plus 2. So y minus 1 equals to minus 3x minus 3 to the 6. Therefore, 3x plus y plus 5 equals to 0. Therefore, the equations of the tangents are x plus y plus 1 equals to 0 and 3x plus y plus 5 equals to 0. Prove that the product of the perpendicular distances from any point and a hyperbola to its asymptotes is constant. So the same kind of problems we have done before also. First Roman, sixth problem. This is the second Roman, sixth problem. Okay. So the concept is same by all respects. But that problem is in the numerical values. We need to show that the product of the perpendicular distances is equals to constant. That is free from x and y is what we need to show. So let the equation of the hyperbola be x square by a square minus y square by b square is equals to 1 or minus 1 equals to 0. So the equations of the asymptotes are x by a plus or minus y by x by a plus or minus y by b equals to 0. That is x by a plus y by b equals to 0 and x by a minus y by b equals to 0. Let from any point, let any point on the hyperbola be P a secant theta, B tan theta on the hyperbola. Now, let PM be the perpendicular distance from P to the asymptote P to 1. Then perpendicular distance or length of the perpendicular from Px1 y1 to the line ax plus by plus c equals to 0 is of ax1 plus by1 plus c by square root of a square plus b square. So this is in the place of x, substitute this because this is x1 y1 point now. This is ax plus by plus c equals to 0. So in the place of x, a secant theta by a plus y in the place of y y1 which is b tan theta by b, constant is missing, by modulus of square of the quotient of x plus square of the quotient of y. So 1 by a square plus 1 by a square plus 1 by b square. So these two gets cancelled. This is equals to secant theta plus tan theta by 1. So this is equals to b square plus a square by a square into b square. So LCM. This is equals to PM is equals to secant theta plus tan theta by 1 into this would be reversed. So a square b square under root is ab by square root of a square plus b square. Now similarly let Pn be the perpendicular distance or length of the perpendicular from P to the second asymptote. Then we'll get Pn is equals to modulus of secant theta minus tan theta by 1 into AB by square root of a square plus b square. Now product of the perpendiculars Pm into Pn is equals to this into this. So secant theta plus tan theta into AB by root of a square plus b square into secant theta minus tan theta by 1 into AB into root of a square plus b square. If you multiply secant theta plus tan theta into secant theta minus tan theta, secant square theta minus tan square theta by 1 into, so AB into AB is AB whole square or a square b square by square and root will be cancelled because root a square plus b square into root a square plus b square is root of a square plus b square whole square. So square root gets cancelled, a square plus b square. Therefore, Pm into Pn is equals to, this value is 1 into this. So this is a square b square by a square plus b square. So which is free from variable x and y. Therefore, the product of the perpendiculars from any point P onto the hyperbola to the asymptotes is a constant. Tangents to the hyperbola x square by a square minus y square by b square equals to 1 makes angles theta 1, theta 2 with the transverse axis of a hyperbola show that the point of intersection of the tangents lies on the curve 2xy equals to k into x square minus a square when tan theta 1 plus tan theta equals to k. So whenever angles mentioned is there in the question or a line is given and parallel perpendicular concept is mentioned, then the thing that should spring to our mind is to take the equation of the tangent in its slope form. So let us take that. Let the equation of the tangent in its slope form be y is equals to mx plus or minus square root of a square m square minus b square. So, show the point of intersection of these tangents. Let p x1 y1 be the point of intersection of these tangents. Px1 y1 is the point of intersection. That means the tangents are passing through Px1 y1. Since Px1 y1 lies on the tangent, implies y1 is equals to mx1 plus or minus square root of a square m square minus b square. So, y1 minus mx1 is equals to plus or minus a square m square minus b square. Squaring on both sides, we get y1 minus mx1 whole square is equals to plus or minus square root of a square m square minus b square whole square. Square root gets cancelled. So this is y1 square plus m square x1 square minus 2mx1 y1 is equals to square and root gets eliminated, a square m square minus b square. This is equals to m square x1 square, this plus a square m square if you bring to this side, minus a square. Take m square in common, x1 square minus a square minus 2mx1 y1. This is y1 square. This minus b square if you bring to this side, it is y1 square plus b square is equals to 0. So, this is clearly the quadratic equation in terms of m square, m and constant. This is a quadratic equation in m. Let the roots be m1 and m2. So, but here m1 comma m2 represents the slopes of the tangents. m1 comma m2 represents slopes of the tangents which we have taken before, of the tangents. So, sum of the roots and product of the roots. Sum of the roots m1 plus m2 is equals to minus b by a x square plus bx plus c equals to 0. So, the roots, sum of the roots are minus b by a. So, minus b means the quotient of m minus 2x1 by 1 by a means the quotient of m square, x1 square minus a square. So, what is m1? m1 is the slope of the tangent. So, m1 means slope m is equals to tan theta, tan inclination. So, tan theta 1 plus tan theta 2 is equals to minus of minus is plus 2x1 by 1 by x1 square minus a square. Given that tan theta 1 plus tan theta 2 to be k. So this is k is equals to 2x1 by 1 by x1 square minus a square. So cross multiplication will get k into x1 square minus a square is equals to 2x1 by 1. Therefore, the locus of the point P x1 by 1 is k into x square minus a square is equals to 2xy. So, this is what we need to prove. show that the locus of the field of the perpendiculars drawn from foci to any tangent of the hyperbola x square by a square minus y square by b square equals to 1 is the auxiliary circle. Auxiliary circle's another definition is this. We have already discussed. So the auxiliary circle's another definition is the circle described on the transverse axis of the hyperbola as a diameter lies on a circle, and that circle is said to be the auxiliary circle, and the auxiliary circle is x square plus y square equals to a square. Ultimately, x square plus y square equals to a square is what we need to show. So that is the concept. Now, let us take the slope form of the tangent. Let the equation of the tangent in its slope form be y is equals to mx plus or minus square root of a square m square minus b square. So, the slope of the above tangent is m. So, foot of the perpendicular. So, let the equation, let the slope of a line which is perpendicular to the above tangent b. So, if its slope is m, then the slope of a line which is perpendicular to this is minus 1 by m. So, therefore, the equation of a line having slope minus 1 by m and passing through the foci. What is the foci? Plus or minus AE comma 0. So this is the foci of the hyperbola. So we have the point and the slope point form. Implies y minus y1, this is 0, minus 1 by m into x minus of minus. So this, let px1 y1 be the locus of the field of the perpendiculars from foci to any tangent of the hyperbola. Since bx1 y1 is the point of intersection of both this line and this line, that means y1 is equals to mx1 plus or minus square root of a square m square minus b square, and y1 is equals to minus 1 by m into x1 plus or minus ae, because these two lines are passing through the point of intersection px1 y1. So since this line is passing through px1 y1, so point has to satisfy this equation. In the similar way, this For this also, the point of intersection is same. Therefore, these are the two equations that we got. Now, so we need to eliminate m here. So this is equals to y1 minus mx1 is equals to plus or minus a square m square minus b square. So this is y1. So this is my1. This minus x1 if you transpose to that side plus x1 is equals to plus or minus ae. y1 equals to mx1 plus mx1 is equals to plus or minus a square m square minus b square. y1 is equals to, so this is cross multiplication. my1 is equals to minus of x1 plus or minus ae. This minus x1 if you transpose to this side plus x1 is equals to plus or minus ae. Now squaring and adding, we get, so this is y1 minus mx1 whole square plus my1 plus x1 whole square is equals to, if we square, then actually this plus or minus whole square is plus, square and root gets eliminated. This is a square m square minus b square plus or minus ae whole square is a square e square. So this is equals to a minus b whole square, a square plus b square minus 2ab. So this is y1 square plus m square x1 square minus 2mx1 y1 plus m square y1 square plus x1 square plus 2mx1 y1 is equals to, this is a square m square minus b square is equals to a square into e square minus 1. So a square into e square minus 1 plus a square e square. Since for the hyperbola b square equals to a square into e square minus 1. So this is what we have got. This is equals to a square m square minus a square e square minus into minus plus a square plus a square e square. So these two gets cancelled, and here these two gets cancelled. So this is y1 square is equals to, so this is y1 square plus m square y1 square plus m square x1 square plus x1 square is equals to this. Now let us take y1 square common in both of them. Then we get 1 plus m square. Here also take x1 square in common. Then we'll get 1 plus m square is equals to, here a square m square plus a square. Take a square in common. So 1 plus m square. So this is equals to, take 1 plus m square common in both of them. Then we'll get x1 square plus y1 square is equals to a square into 1 plus m square. So these two gets cancelled. So this implies x1 square plus y1 square is equals to a square. Therefore, the locus of Px1 y1 is x square plus y square is equals to a square, which is the auxiliary circle. Show that the equation x square by 9 minus c plus y square by 5 minus c equals to 1 represents an ellipse if c is a real constant less than 5, a hyperbola c is between 5 and 9. Show that each ellipse in 1 and each hyperbola 2 has Foci at the 2 points plus or minus 2 comma 0 independent of the value c. So this equation, given equation is x square by 9 minus c plus y square by 5 minus c equals to 1. So this equation represents an ellipse if x square by a square plus y square by b square. So a square, that means this should be greater than 0 and this should be greater than 0. 9 minus c is greater than 0 and 5 minus c greater than 0 because x square by a square. So something square is always positive. Y square by b square. B square means this should be b square. Something square is always positive. So from this, 9 minus c is greater than 0. 9 is greater than c. In other words, c is less than 9. And 5 minus c is greater than 0. So 5 is greater than c. Otherwise, c is less than 5. That means this is 5 and this is 9. The c value is less than 5 and c value is less than 9. That means c value is less than 5 in both this condition. C is less than 5. Therefore, c is less than 5. So the next condition is the given equation represents the hyperbola. The given equation represents hyperbola if x square by a square minus y square by b square. That means x square by a square. This is positive. 9 minus c is obviously positive. This is y minus y square by b square. This is minus b square. That means this should be less than 0. 5 minus c is less than 0. So this is 9 is greater than c or c is less than 9 and 5 is less than c or c is greater than 5. That means this is 5 and this is 9. So c is greater than 5. C is less than 9. So both are intersecting at here, this region. That means C is lying in between 5 and 9. So that's what we need to prove. Between 5 and 9. And show that each ellipse in 1 and each hyperbola 2 has foci at 2 points. So in case of ellipse, that is the first case, a square minus b square is equals to, what is a square here? 9 minus c minus, what is b square? 5 minus c. So this is equals to a square minus, in ellipse b square is equals to a square into 1 minus e square is equals to 9 minus c minus 5 plus c. C gets cancelled. 9 minus 5 is 4. This is a square minus a square minus into minus plus a square is equals to this. So a square e square equals to 4. That means ae is equals to plus or minus 2. Therefore, the foci for ellipse is plus or minus 2 comma 0. That's what we need to show. And in case of hyperbola, a square plus b square is equals to 9 minus c plus B square is 5 minus C here. B square is C minus 5 because this should be less than 0, right? So this is C minus 5. C gets cancelled. 4. This is equals to 4. A square. B square values A square into E square minus 1. So this is A square plus A square E square minus A square is equals to 4. A square gets cancelled. A square E square equals to 4 again. So AE is equals to plus or minus 2. Therefore, FOSSI for hyperbola is also the same, plus or minus 2 comma 0. This is x square by a square plus y square by b square. A square is b square is this for ellipse. But this value is for hyperbola. This value is less than 0. 5 minus c is less than 0 or c minus 5 is greater than 0. So actually this is c minus 5 we have taken. Let us see this example. A circle cuts the rectangular hyperbola xy equals to 1 in the points x r, y r, where r is 1, 2, 3, 4. Prove that x1, x2, x3, x4 is equals to 1 and y1, y2, y3, y4 is also 1. So since the equation of the circle is not given, let the equation of the circle be x square plus y square is equals to a square. Since the point t comma 1 by t lies on the rectangular hyperbola xy equals to 1, because t comma 1 by t satisfies xy equals to 1. So t into 1 by t gets cancelled is equals to 1. Now the point of intersection of the circle and the rectangular hyperbola is solving 1 and 2. So this is x is equals to t. So t square plus y is 1 by t whole square is equal to a square. So this is t square plus 1 by t square. So LCM is t square into t square t power 4 plus 1 is equals to a square. So this is t power 4 plus 1 is equals to a square t square. So this is t power 4 plus 0 t cube minus a square t square plus 0 t plus 1 equals to 0. So this is a biquadratic equation. So since this is a biquadratic equation, it has 4 roots. Power 4, degree is 4. So it has 4 roots. Let the roots be T1, T2, T3, T4. So product of the roots is equals to T1, T2, T3, T4. That is equals to 1. We have seen this in the theory of equations in part A. So here minus P1 by P0, which T1 plus T2 plus T3 plus T4, some of the roots, and product of the roots taken 2 at a time. So this is P2 by, So this is plus, minus, minus of minus. So P2 by P naught. Likewise, taken 3 at a time, taken 4 at a time. So this by P power 4 quotient is 1. So this is what we'll get. If XR, YR is equals to X is TR, comma 1 by TR, where R is equals to 1, 2, 3, 4, then T1, T2, T3, T4 is equals to X1, X2, X3, X4. So this is equals to 1 by T1, 1 by T2, 1 by T3 into 1 by T4 is equals to Y1, Y2, Y3, Y4. So this is equals to 1 by T1, T2, T3, T4. So 1 by 1 is equals to 1. So this is what we need to prove.